Okay, guys, welcome back to another Algebra 2 lesson. Today we are starting the FG3 notes, which is all about transformations of functions. So really this year, this is the first new Algebra 2 content that you've seen. You may have talked a little bit about transformations in Algebra 1, but it's a pretty big focus here in Algebra 2. So we are finally into some new information. You did a lot of work with transformations in geometry, and so we're going to carry over some of those ideas that you had in geometry now into Algebra 2 and see their application in essentially graphs. So let's start with the idea of symmetry. So there are two basic classifications for functions that we have in Algebra 2 where we talk about symmetry. We have even functions and we have odd functions. These are the primary two classifications of symmetry that we're going to talk about in this class. So even functions, how we define an even function has to deal with the input and output of the x coordinates. Essentially, if I take a function, so remember this function notation, f of x is a y value, x is a x value. So let's say I take f of x and I make x negative instead of positive. That's going to be the same as f of x. Or essentially, if I switch the sign of my x value, the y is going to stay exactly the same. It's going to have the same number on both sides for on both x values for the y value. What this does in terms of the graph and symmetry is it creates symmetry about the x-axis. Sorry, not the x-axis, the y-axis. Symmetry about the y-axis. Essentially, you talked about reflections in geometry. You talked a lot about reflections. And so if we can reflect a point across the y-axis and it maps onto another point, and we can do that for an entire graph, that is an even function. It has symmetry about the y-axis. So if I take a look at this function here shown on the board, now you don't need to worry about what this function is right now. You may know it, but what we notice here is that this has symmetry about the y-axis. So if I click on a point here, say this point right here. Sorry, let me find it exactly. 2, positive 4, 2, 4. Actually, let me pull up the table, and we can see the table a little bit better. So we'll see 2, 4 is this has the same value. So x, when x is positive 2 and x is negative 2, they have the same y value. When x is positive 1 and when x is negative 1, they have the same y value. If we continued when x was positive 3 and x is negative 3, they'd have the same y value. And so this is an even function. Now, if I start moving this function around, let's say I'm sliding it up or sliding it down, it's still an even function. So notice these 2 points, negative 2 and positive 2, still have the same y value. This point, negative 1 and positive 1, still have the same y value. So if I slide it up and down, it's not really going to change whether it's even or odd. But now let's say I start moving this function left to right. Oh, so here we see a difference. So now negative 2, if we look over here at the table, negative 2 has a y value of 0. Positive 2 has a y value of 16. So I can't even really see that. Let me shoot it, get a little bit closer here. So negative 2 has a value of 1.96. Positive 2 has a value of 6.67. Negative 1 has a value of 0.16. Positive 1 has a value of 2.56. So this is not an even function. Opposite x values do not have the same y value. And it does not have symmetry about the y-axis. The other type we have is what we call an odd function. So when odd functions, if I take x and I change its sign and from positive to negative, that's going to change the sign of y as well. So opposite x values are going to have opposite y values. This creates symmetry about the origin. And really this symmetry is a rotation. It's a rotation 180 degrees around the origin to create symmetry where the function would map onto itself. So we can see that in this example. Let me readjust my sliders here. There we go. So now if I pull up a table, opposite x values should have opposite y values. So when x is negative 1, y is negative 1. So then when x is positive 1, y should be positive 1. Opposite x's have opposite y's. You can see that on the table as well. When x is negative 2, y is negative 8. When x is positive 2, y is positive 8. So the numbers remain the same, but their signs switch. When the x sign changes, the y sign must also change. Now, let's take a look at sliding this one up and down. Oh, sorry, I'm moving it left to right here. Let's slide this one up and down. So in the previous example, if I had symmetry about the y-axis, if I slide it up and down, nothing changes. Here, when I slide it up, if I take a look at 1, positive 1 has the y value 3. Negative 1 has the y value 1. So these y values are not opposites when the x's are not opposite, or when the x's are opposites. So this would not be considered an odd function. If I slide this left to right, I'm going to see that occur as well, that it's no longer going to be an odd function. So if I slide it left to right, when we'll look at the table here, when x is positive 1, y is negative 0.027, and when x is negative 1, y is negative 0.12 or negative 12.167. So the y's are not opposites. When the x's are opposites, this is not an odd function. So we can look at functions graphically, and we can look at them algebraically to determine if they're even or odd. So let's take a look at problem number 1. It says, consider the partial graph of the function f of x shown in both of the graphs below. Sketch the other half of the graph, or sorry, the function, to meet the requirement shown in part A and in part B. So in A, we want this to be an even function, meaning we want it to have symmetry about the y-axis. So if you want to pause the video and see if you can create that, go ahead. What I'm going to do here is I'm going to take a look at the points. So this point right here is 3, 5. This point here is 7, 2. So when the x's are opposites, the y's should stay the same. So to be even, 3, 5 should have a corresponding point, negative 3, 5. So I'm going to go ahead and map that one. 7, 2, sorry, this should be 7, negative 2. 7, negative 2 should have a corresponding point, negative 7, negative 2. So I'm going to go ahead and map that one. From here, we can, for this one, we could just connect the dots in order to create a function that we believe to be even. And if I take a look at that graphically, I can see that this does have symmetry about the y-axis. The y-axis is the vertical axis, and so this would be an even function. So you can do that by taking a look at it visually and graphing the points that way to have a reflection across the y, or symmetry about the y-axis, or we can take a look at the points' coordinates and map those accordingly so that it's going to be in the correct location to be an even or odd function. In B, we need an odd function. So what does that do to the points? If I switch the x coordinate, the positivity or negativity of the x coordinate, I have to do the same for the y. So positive 3, positive 5 should have a point, negative 3, negative 5. To be an odd function. If I change the x, I also must change the sign of the y. Sorry, that's negative 3, negative. Let me count that again. 1, 2, 4, negative 3, negative 4. I need to bump that down a line. Let's try this again. 1, 2, 3, 4, 5. There we go. Negative 3, negative 5. Sorry about that. Same thing should happen for the other point. So 7, negative 2. If I switch this to a negative 7, this should change to a positive 2. So negative 7, positive 2. Now I could connect these dots. If you wanted to plot more points in between, you could, but if you kind of see the pattern here, I can connect these dots. Oops. And there I have my odd function. It has symmetry about the origin. So we can, again, look at that graphically or algebraically. Now in problem number 2, it says, determine whether each of the following functions are even, odd, or neither. So we're going to do both in this case. We're going to look at this graphically, and we're going to look at this algebraically. So graphically, what I'm going to do this first. I'm going to just type that graph into my calculator. I'm going to type in under y equals, I'm going to clear anything that's in there. and I'm going to type in x cubed minus x squared, and then I'm going to reset my window because it was wacky there, so I'm going to set it to zoom 6, and this is the graph that we see. So I can kind of sketch this graph here if I'd like, get an idea of what it looks like. And again, here's the graph. So it looks something like this. Sorry, it's not a great picture. Let's try that again. It looks something like this. So if I wanted to, I can zoom in and hit the zoom key and zoom in to get a little closer picture of it. You can see that graph comes up, dips back down, and turns around and goes back. And so this one, we would say that, is there symmetry about the y-axis, the vertical axis? No, there's not. Is there symmetry about the origin? Could you rotate it 180 degrees to map it onto itself? No, that's not the case either. So this is neither. If I wanted to do the same thing algebraically, what I would do is take the opposite of x and see what's going to happen in this equation. So I'm going to substitute in a negative x for all of the positive x values and then simplify this expression. So first I need to cube a negative number. If I cube a negative x, it's going to stay as negative x cubed. If I cube x squared, that's going to change it to a positive x, so this is going to be minus x squared. So now I want to compare the signs of the opposite of x that we just substituted in to the signs of wx. To be even, the function should be exactly the same, and they're not. To be odd, each one of the terms should have a different sign. So we can see this one was positive and now it's negative. Okay, that's good. This one was negative, but it's still negative, so that's not good. This is neither even nor odd. Okay, so if you're looking doing it algebraically, if all of the signs switch, it's odd. If all the signs stay the same, it's even. And if something else happens, it's neither. Let's go ahead and take a look at number 2, and let's do it graphically first. So I'm going to type in this function, 3/4 x squared plus 3 absolute value of x. And I'm going to go ahead and go back to the normal window here when I graph it. I'm going to sketch out this function. So it looks kind of like an absolute value function, kind of like a quadratic function. We've got something that looks like, oh, sorry, gotta get on the pen here. We've got something that looks like this. Okay, we can zoom in a little bit if we wanted to. It should touch all the way to the axis. But we got something that looks like that. And we can take a look at this graphically. We can take a look at this picture, and we can see that this does have symmetry about the y-axis. So we would say that this is an even function. Now, algebraically, if I put in a negative value for x, I would need to substitute in a negative x anywhere where we see x, and then simplify. So this would be 3/4 positive x squared, because when you square positive, it becomes, or negative, it becomes positive. The absolute value would get rid of that negative inside the x, and so we see that the opposite of x, when I substitute in a negative x, it's the same as the original function, which means that this function is definitely going to be even. So if you can substitute those in and it's the same, this is an even function. Let's go ahead and take a look at the last one. It's kind of an ugly expression here, but let's first type this into the calculator to graph it. I'm going to hit y equals. I'm going to clear this out. I'm going to type in 2. The cubed root is under the math button. So if you hit the math button, go down to that 4th option. That's where your cubed root is at. And then minus 1/4 x cubed. And now let's graph that picture. have something that looks like this. So let's sketch this in. It looks something a little bit like that. Not perfect, but we kind of get the idea. It looks like this might be an odd function. We might look at this and say this has symmetry about the origin, so this is odd. So that's a good place to, kind of a good assumption to make. Let's check that algebraically. So if I put in a negative value for x, I need to do that for each x, replace it with a negative x, and then simplify. And so the cubed root of a negative number, so like the cubed root of -1 is going to be -1. So cubed root of a negative number, this negative is going to come out in front now. If I take the cubed of x, sorry, negative x, it's going to be negative. So that's going to change my 1/4 from negative to positive because I'm going to have two negatives being multiplied. So this would be the opposite of x. Now let me go ahead and compare that to the original function. Well, the first term has a different sign, and the second term has a different sign. So both terms in this have opposite signs. This would be an odd function. So this is essentially all that there is to even and odd functions. For even and odd functions, we are looking for symmetry about the origin, it's odd, or symmetry about the y-axis, it's even, or we might be looking at if it has neither of those cases, it would be neither even nor odd. We can do that algebraically as well by substituting in a negative x. Now, last thing that we have to do is we are going to take a look at the toolbox functions. There are 6 functions that essentially make up the main component of Algebra 2 in terms of how we look at graphs. So these are referred to as the toolbox functions. And so we're going to graph each one of those. So what you should do at this point is go ahead and pause the video, type each one of those functions into your calculator, and graph those. So those are on page 3. Sorry, 2 and carries over to page 3. Go ahead and graph them. Use your tables function if you need to. So like if I wanted to graph the first one, I'm going to go ahead and put in y equals x. I'm going to take a look at this graph. If I need to, I can hit the table and plot some points to help me get some points along the way there. But we want to graph each of those 6 functions. Once you have finished, then play the video and we'll pick it up a little bit. Okay, hopefully you've graphed each one of these functions. I'm going to change the directions slightly. We're not going to talk about increasing or decreasing intervals yet. I'm not going to talk about end behavior. We will talk about initial points. So if we take a look at 3a, this is a line. We did want to list domain, range, and symmetry for this function. So remember, domain is all x values. And this function hits all of the x values. It's going to go to the left forever. It's going to go to the right forever. So the domain is going to be all real numbers. The range will be the same thing. Range is all of the y values that are eventually going to be part of the function. And it goes up forever. It goes down forever. So the range will be all real numbers as well. In terms of symmetry, hopefully you notice that this is an odd function. It does have symmetry about the origin. You could rotate it 180 degrees about the point 0, 0, and it will map onto itself. Its initial point is 0, 0. So it goes through the origin. Most of these functions are going to have an initial point of 0, 0. Let's take a look at the second function. This is an absolute value. So we've looked at absolute value equations. Now we have a graph of an absolute value. The domain for this function is also all real numbers. Stretches to the left forever, stretches to the right forever. The range, however, is different. The range, we may notice that this never gets below the x-axis. So the range is all numbers that for y that are greater than or equal to 0. This function is an even function. So it has symmetry about the y-axis. Its initial point is also 0, 0. So where it changes from decreasing to increasing is at 0, 0. That's going to be the initial point that eventually we'll use for transformations. Going on to C. In C, we have a quadratic function, and we're going to learn a lot about quadratic functions this year, but for right now, let's just take a look at the basics of its graph. The domain for this function is all real numbers. The range for this function is greater than or equal to 0. So like the absolute value, it never gets below the x-axis without transformations. And so it's going to hit all y values from 0 and above. This is also an even function. It has symmetry about the y-axis. Its initial point, see some consistency here, is 0, 0 before transformations. Taking a look at D, we have a square root function. This one is going to be a little bit different than what we've seen. The domain for this function is not all real numbers. So notice that on the x-axis, it's only going to the right. It never passes the y-axis to the left. So the domain is going to be any x that's greater than or equal to 0. The range will actually be the same for the y, so it never goes below the x-axis. It does go above forever as we go to the right, so the range is going to be greater than or equal to 0. This is neither an even nor an odd function, so this function does not have symmetry. It does have an initial point, and its initial point is the same as the previous function, 0, 0. The last two, e, is our cubic function. The domain for this function should have been all real numbers. The range for this function should have been all real numbers. This function does have symmetry. This is an odd function, so it does have symmetry about the origin. It does also have an initial point. Like the rest, it's at 0, 0. Finally, the last one, the cubed root function. It does go to the left forever and to the right forever, so its domain is all real numbers. Its range is all real numbers. This function is an odd function. It also has an initial point of 0, 0. So these are our 6 basic functions that we are going to use to take a look at transformations in this target, but also throughout the year as we progress into Algebra 2. This is a good place to stop for part 1 of the notes. So on Monday, we'll take a look at questions that you guys may have. We'll take a look at some homework problems, and then we will progress on into the specifics and transformations. Thank you guys for tuning in, and I'll see you soon.